Assalamu alaikum everyone. This is Group 1 presentation. Communication Principles Ericsson Case Study. So, Group 1 members are Ahmed Al-Said Amir, Ahmed Gamal Al-Said Hussein, Ibrahim Hassan Abdul Fattah Ahmed, and Hassan Mustafa. So, before we proceed, I want you to pause the video, scan this code. It will lead you directly to a quiz we made. Please solve this quiz and then you shall proceed. So now I assume that you have already solved the quiz. Now we move on to our agenda. Our agenda contains the introduction, digital modulation, sampling theorem, multiplexing, and finally recent advancement in telecommunication. So for the introduction, telecommunication networks are transitioning to a digital future. Several telecommunication components such as transmissions, lines, and switches are being converted to a function using a digital signal. As a result, information signals must be converted to a digital format in order to be communicated across the network. There are several advantages and disadvantages of this adopting digital modulation in telecommunication systems. What is digital modulation? Well, it is a technique of embedding a digital information signal into the amplitude, phase, or frequency of the transmitted signal. The encoding technique has an impact on the transmitted signal's bandwidth and resistance to a channel degradation. Advantages digital modulation. So the advantages of digital modulation, we have four main advantages which are easy to measure, store, and process. It enables encryption. It also can be multiplexed, and it has immunity to noise. The disadvantages, or the four main disadvantages of digital modulation are: it needs to be synchronized, it has a bigger bandwidth, analog signals need to change to digital first, and not compatible to an analog system. So for sampling theorem, the Nyquist sampling theorem asserts that if the waveform is sampled twice as rapidly as its highest frequency component, a band-limited continuous time signal may be sampled and properly reconstructed from its samples. So proper sampling, when the samples can be used to precisely rebuild an analog signal, the samples include all of the required data to retrieve the original wave. So methods of sampling, we have three. The first one is instantaneous sampling. So instantaneous sampling, it is not a practical method, okay? And the flat top sampling is the method. The method is also used practically, and the natural sampling, this method also used practically. Okay. Pulse modulation is a type of modulation in which the signal is transmitted in the form of pulses. It can be used to transmit analog information in pulse modulation. Continuous signals are sampled at regular intervals. Pulse modulation can be more classified into two major types: analog and digital. Analog is the indication of sample amplitude in infinity variable, and the digital indicates samples amplitude at the nearest predetermined level. So the types of modulation we will be concentrating today, and our focus will be on the pulse modulation, which is considered in two types: analog modulation and digital modulation, which is also can be classified in four types: three for analog and one for digital modulation. And these are the PAM, PWM, PCM, PPM. So the PAM, which is the pulse amplitude modulation, it is the message information is contained in the amplitude of a series of signal pulses in a pulse amplitude modulation. A type of signal modulation, the amplitudes of a train of carrier pulses are adjusted according to the sample value of the message signal in the analog pulse modulation system. The pulse width modulation, the PWM, also known as a pulse duration modulation. It is a technique for decreasing the average power produced by an electrical signal by breaking it up to a discrete portion. So by rapidly rotating the switch between supply and load and off, the average value of voltage provided to the load may be regulated. So the PPM also, we have the PPM, which is the pulse position modulation. It is a signal modulation technique in which the M message bits are encoded by sending a single pulse in one of the needed time shifts. This is done every seconds, okay, every t seconds, resulting in a bit rate of bits per second being broadcast. And finally, we have the PCM, which is pulse code modulation. Pulse code modulation is a method used to present an analog signal in terms of digital word constitutes three processes. The first is sampling the analog signal. The second is quantization of the amplitude of the sampled signal. And the third is coding of the quantized sample into digital signal. So sampling, quantization, coding. We are going to take a look of the disadvantages and advantages of each one. So the PAM, the pulse amplitude modulation, the disadvantages that it has a large bandwidth and the amplitude is varying, therefore the power required will be more, so it uses more power and it has more noise. The advantages is that both modulation and demodulation are simple and it is easy construction of transmitter and receiver circuits. The applications is mainly used in Ethernet communication, and many microcontrollers use the technique in order to generate control signals. It is used in photobiology. It acts as an electronic driver for LED circuits. The pulse position modulation, the PPM, the disadvantage is that the system requires more bandwidth and the system is highly complex. The advantage is that it requires less power. We can easily separate signals from a noisy signal. Among all three types, it has the most power efficiency. So it has the most power efficiency among all the other three types. So its applications it is used in the air traffic control system and telecommunication systems, remote controlled cars, planes, trains use pulse code modulation. It is used to compress data and hence it is used for storage. Pulse code modulation, PCM, the disadvantages are it has more bandwidth, the more bandwidth required, so it requires more bandwidth, okay, when compared to analog system, and in the method encoding, decoding and quantization of the circuit have to be done. This makes it more complex. Advantages, it is mainly used in long distance communication, transmitter efficiency is more, and it has higher noise immunity when compared to other methods. Its applications are, it is used in the satellite transmission system. It is also used in space communication, used in telephony. One of the recent applications is the compact disc. Finally, the pulse position modulation, the PPM. Disadvantages are the circuit is more complex, voltage spikes can be seen, switching losses will be more due to the high PWM frequency. The system is expensive as it uses semiconductor devices. The advantages are low power consumption. It has an efficiency of about 90%. The noise interference is less. The applications are It is mainly used in Ethernet communication, and many microcontrollers used this technique in order to generate control signals, and it is used in photobiology. It acts as an electronic driver for LED circuit. So we move on to multiplexing. Multiplexing is a way of combining numerous analog or digital signals into one signal via a common media in telecommunications and computer networking. The goal is to pool a limited resource. Now you can take a look in telegraphy timeline. It was invented in the 70s of the 19th century. So here we have the types of multiplexers. It has two main types, analog and digital. Analog has two types, FDM and WDM, and digital has the TDM, which contains of two types, synchronous TDM and asynchronous TDM. So for the analog multiplexing, the FDM is the most common technique in multiplexing. It combines streams of data for sending them on a communication medium as a single signal. In WDM, many data streams of different wavelengths are transmitted in the light spectrum. For digital multiplexing, the main difference between synchronous TDM and asynchronous TDM that in asynchronous TDM, if the allotted device for a time slot transmits nothing and sits idle, then the slot is allotted to another device, unlike synchronous. Move on to applications on multiplexers. We have analog and digital broadcasting, telephony, video processing, and telegraphy. So you can see here the advantages and disadvantages. We move on to the last part of our presentation, which is the recent advancement. 5G technology. What is 5G technology? 5G is the fifth generation of wireless network technology. It offers faster download and upload, also allows for more connected devices at the same time. Well, before 5G, the fast internet speed was up to 100 megabytes, and it was up to 4,000 devices supported per square kilometer. Now with 5G, we expect the download speed to be over more than 10 gigabytes, okay, 100 to 1,000 times faster than the preceding generation, and we expect it to be up to 1 million devices supported per square kilometer. Health and safety misconceptions. There are concerns about the risks of 5G are unfounded. Does 5G technology pose health risks? Well, studies have proven that these allegations are unfounded. Also, the experts have expressed that there are no factual bases for claims that say 5G poses risks to people's health. So consumers also need to be educated more on how 5G works. You are ready to challenge yourselves by this game. You can find it on Ericsson website. You can easily scan this barcode and it will lead you directly to the game. Now, after you watched the video and acquired the knowledge and completed the game, I believe that you are ready to try our quiz. You can scan this barcode and challenge yourselves and also memorize. That's all for our presentation. Thank you.